in this session, I would be talking about this serverless computing with Azure Functions topic. And here, before starting, I hope you guys, as this is the last session of this series, and you had some other sessions about cloud computing and Azure and the services we have in Azure. So I hope you guys have some kind of a basic understanding about cloud computing and Azure and the related services and all the things. So I'll be doing this session based on this assumption. So if you guys have any unclear points or unclear places, please interrupt in between the session. So I'll try my best to explain these things to you guys. So let's try to have a kind of more interactive session here. So hope you guys can learn something from this session. So yeah, first of all, let me introduce myself. I forgot about that. So I'm Lahiru and I'm an associate technical lead in 99X here. So yeah, that's about me. And all right, let's start from the agenda. So these are the things I'm going to cover in this session. First of all, I'll give you guys a small introduction to serverless computing, this term called serverless computing, and then let's look at the Azure Function apps. This is kind of the main service we are focusing in this session, and we can see what are the features and what are the capabilities we have in Azure Function apps and all the things here. And then, of course, I think you guys had this session on Azure App Services, and sometimes you guys can have some confusions. I mean, right after we do the introduction to Azure Functions, function apps, so you guys may have some confusions. I mean, these two services, some kind of similar, but the way it works is totally different. Not totally, but it's kind of different. So let's try to clear the things about the core differences in between Azure App Services and Azure Function Apps, so that uh, I mean, very clear about these two services to you guys. And then, of course, I have prepared two demos. One is in the first demo, we'll try to we will create a new app function app resource in the Azure portal, and then of course we are going to create a project uh, project for Azure function apps, and there we will be implementing different functions and all the things. And finally, we'll deploy that code base to our Azure resource, and we can try out things there. And in the second demo, what I'm going to do is that we can connect other services like Cosmos DB, service buses, and those other services with this Azure function apps. So I'll be covering this integrating part in the second demo, and hope these two demos will give us and better understanding about how Azure function apps are working. And of course, in the final section, let's talk about Azure durable functions. This durable function is an kind of extension of Azure functions. So hope to finish the session from discussing the durable functions so that you guys can have a holistic and more complete knowledge on Azure function apps. Yeah, that would be the agenda. So let's start from this section, introduction to serverless computing. So, uh, okay, the first question would be, what is serverless computing? You know, we can say serverless computing as a cloud computing model. So, in today's era, we have different computer models and different cloud computing models. Serverless computing is a cloud computing model. So basically, you know, we have different cloud providers. For an example, we have Azure, we have AWS and GCP uh, cloud providers as select. So in serverless computing model, these cloud providers are automatically managing the underlying infrastructure. So as developers, from our perspective, we don't see this underlying infrastructure. So uh, they dynamically allocate resources based on the application demand, the traffics, and all the things. So the point is, this underlying infrastructure, managing the management of this underlying infrastructure part is not visible to us, the developers. So here, you guys can maybe confused with the term this serverless. It's, I mean, even though the name depicts the serverless, it does not mean that there are no servers in serverless uh, resources. So basically, the point is these underlying servers and other related infrastructure are managed by the cloud provider, and it's invisible from the end user. That's why we call this serverless computing. And yeah, as I mentioned, serverless does not mean that there are no servers. Instead, the management of servers is abstracted away from the developers. Yeah, sorry guys. And then yeah, the next point is the serverless name. It's showing the same point. The serverless name comes from the fact that the task associated with infrastructure provisioning and management are invisible to the developers. So I hope this point is clear to you guys. Yeah, okay. Then let's talk about some of the key characteristics about serverless computing. Uh, First point is it's kind of automatic scaling. The resources are provisioned and scaled dynamically based on the traffic of the data. It ensures that the application can handle varying workloads without manual intervention. That would be the key characteristic, the first key characteristic. And then, of course, it's event driven. For an example, serverless functions are triggered by events. Here, the events such as HTTP requests, database changes, or message from a queue, events such as that. So basically, these serverless functions are triggered from these events. So that's why we called it event driven. And in most of the cases for serverless computing resources, we have this pay as you go pricing. So with serverless, you pay only for the compute resources used during the execution. So which can be cost effective in many scenarios. And of course, in most of the scenarios, I'll explain this stateless and statefulness in the coming slides. But anyway, in most of the scenarios, when it comes to serverless computing, uh, it's kind of stateless. So uh, it's typically stateless, meaning they don't store the data between these function invocations. So if you are to manage states, uh, when using serverless computing, you have to manage those states internally or in a stateful service like a database. So yeah, that's about it. And yeah, the final point is microservices. Serverless is a kind of often used to build and deploy small single purpose functions that work together to form a larger application. So you know that we can have multiple these serverless components and put together and build a larger scale applications. So yeah, these are the, I mean, kind of key characteristics of serverless computing. And yeah, then let's talk about the benefits of using serverless computing. And I talked about this point, the first point, no infrastructure management. So basically this uh, the infrastructure management part is done by the cloud providers by themselves. So using this kind of fully managed services enables developers to avoid administrative tasks and focus on the core business logic. So with a serverless platform, you simply deploy your code and it runs with high availability. So it's kind of a benefit we can get from serverless computing. And the second benefit would be the dynamic scalability, where with serverless computing, the infrastructure dynamically scale ups and scale down. In the, I mean, when it comes to scaling, if I explain to you guys, scaling out in the sense we add more instances into the underlying infrastructure to handle the increasing demand for resources. And the other way around, the scaling, the other way around would be the removing the instances from the underlying infrastructure, since there are no any high demand for the resources. So basically, this is handled by the uh, cloud providers themselves, so we don't need to worry about this. So basically, the dynamic scaling options are available in serverless computing. And the third point would be the faster time to market. So as I mentioned, you don't have to worry about the underlying infrastructure and all the things. So it will ultimately, as the developers, we can focus more on the business logic, the business value delivery. So it will ultimately resulting the product to uh, go to the market in a faster manner. And the last benefit would be a more efficient use of resources. So shifting to serverless technologies helps organization to reduce the total cost of ownership and reallocate resources to accelerate the pace of innovation. So here there are several benefits as this when using serverless computing, but the main point I want to highlight here is that, guys, you know, in every computing model, there are several benefits we can gain. But the main point is for every scenario we come up, like we have different projects, right? The requirement is different in every these projects. So the the main point is to understand is that, so for every scenario you have to implement kind of a system. The serverless computing might not be the best option. I mean, it depends on the situation. So, but since we are talking about serverless computing here in this session, so I'm highlighting the benefits from using serverless computing. But as I mentioned, the point is, depending on your situation or the system, the requirement, you have to decide whether to use serverless computing or not. So yeah, hope this is clear, guys. And yeah, so that would be the end of the first section. Do you have any questions, guys? I mean, any unclear places or here in the serverless computing section? Any questions, guys? Yeah, all right. So then we can move to the next section. So here I'm going to give you guys an introduction on Azure Function app. So this is the main resource, the main Azure resource we are considering in this session. So yeah, let's move on. Okay, so let's start from here. So what are Azure Function apps? So Azure Function apps are a serverless compute service provided by Microsoft Azure. So basically in Azure, you have several serverless compute options, such services as Logic apps and Azure Function apps is one of those serverless options. So when it comes to this particular service, Azure Function app, it's just one option in Azure. We can choose to implement serverless uh, kind of systems. And in Azure Function apps, it's kind of small pieces of code called functions. In Azure Function, in a single function app, we can have multiple functions. We can identify these functions as small pieces of code. And so, as I mentioned, in a single Azure Function app, you can have multiple functions, and you don't have to worry about the infrastructure, the underlying infrastructure, so as it is managed by the provided by themselves. And yeah, so I put this diagram, architectural diagram here, so that I will be able to give you guys a better understanding how Azure functions are working. So here you don't let me, yeah, you just need to pay attention to here, not here, this one, this part. So let's take this highlighted part is a single Azure function app. So inside that function app, you can have several functions as this. And for this function app, you can have data inputs from other services like this. So, and also from the function app itself, from the functions themselves, there can be output bindings as well, like this. So for an example, in this architecture diagram, we are getting request from this rideshare web app, and the processing part is done in the function app itself, and the output uh, we are sending the output data to this event grid topic. So when it comes, I mean, I'm not going to explain in detail about these services, the other services, but my point is that the Azure Function app is kind of this kind of system. There you can have multiple functions, and there can be many ways of data inputs, input bindings, and there can be many ways of output bindings as well. So that's the main point here. So I hope the full picture is clear to you guys. And then let's talk about the programming language options we can use for Azure functions. So we can use C Sharp, Java, JavaScript, PowerShell, and Python. So I mean, the options are great. So you can choose whatever the programming language option you prefer to start working with Azure functions or the function apps. And yeah, and then let's talk about the core features and capabilities of Azure functions. So I explained these characteristics in serverless computing as well, but anyway, let's go through this. So Azure functions are event driven. So as I mentioned, I mean, for Azure functions, there are many types of triggers. I mean, kind of events like HTTP request, timers, database changes, file uploads, and many more. I'll explain these triggers in coming slides. Anyway, the point is the Azure functions are event driven, and we have this auto scaling options. And of course, in some scenarios, we can manage this scaling manually as well. But yeah, I'll explain this in coming slide as well. So in general, Azure functions automatically scale based on demand, ensuring the optimal performance. And then, of course, you have this pricing model, pay as you go. You only pay for the resources consumed while your functions are running, make it a cost-effective solution. And yeah, those are the core features and capabilities. And then I mean, before going deep into Azure functions, you have to have a better understanding about these two terms, triggers and bindings. So here, let's start from the triggers. So triggers causes a function to start. It's kind of the event we talked about in the earlier slide. So basically, triggers causes a function to run. A trigger defines how a function is invoked, and a function must have exactly one trigger. So for a single function, you can have only one trigger. It can be a HTTP trigger, and it can be a timer trigger. You can have a queue trigger. So, but the thing is, for a function, there is only one trigger, and triggers have associated data, which is often provided as the payload of the function. So with the, for an example, let's say a queue trigger. So with this queue trigger, we can associate the queued message as data, and we can provide this data into the function as the payload of this trigger. So hope it's clear to you guys. And then let's talk about this term bindings. So binding to a function is a way of declaratively connecting other resources to the function. So, in Azure, we have different resources like service bus queues, Cosmos DBs, I mean, other Azure SQL databases. So we can connect these different types of resources to a function using bindings. So when it comes to the bindings, you can mainly have two types of bindings: input bindings and output bindings. So for a particular function, you can have uh, either input bindings or output bindings or both. So as the name depicts, input bindings is used to input data, and output bindings are used to put data from the functions into other resources. So yeah, so hope these two terms are clear to you guys: triggers and bindings. And then yeah, so I have added some example scenarios to explain these triggers and bindings. So let's go one by one so that you guys can have a better understanding here. So the first example is there's a new queue message arrives, which runs a function to write to another queue. Here, the function is triggered by this queue message. So there the trigger would be queue, and there will be no any input bindings. But from this function, we are to write to another queue. So in this scenario, the output binding would be again a queue. Here the queues in the sense there could be a service bus queue or storage queue. Anyway, the trigger here, the trigger would be a queue, and also output binding also be a queue. And then the second scenario, a scheduled job reads blob storage content and creates a new Azure Cosmos DB document. So here the function is triggered by a scheduled job, which means the trigger is a timer. So when this function is invoked, it reads data from this blob storage. So the input binding would be a blob storage, and then it process the data and create this new document in this Cosmos DB. So the output binding would be Azure Cosmos DB. And the third scenario is the event grid is used to read an image from blob storage and a document from Azure Cosmos DB to send an email. So yeah, so I'll explain. I mean, I'm not going to explain in detail about what this event grid is. So basically, event grid is a separate service available in Azure. So we can say it's a highly scalable or fully managed pub sub message distribution service. So with that, we can kind of use this service to publish messages. So I hope it's that this explanation is sufficient for this scenario. So basically here the event grid, we use this event grid messages to trigger the function. So the trigger would be event grid and input bindings. So here we see two input bindings. One is we are getting an image from the blob from a blob storage and a document from Azure Cosmos DB. And then the input bindings would be the blob storage and Azure Cosmos DB. And then finally, after processing data, we are to send an email. So uh, since we are sending an email, the output binding would be SendGrid. So here this SendGrid is a separate service as I mean other services here in Azure. So you can use this service to kind of have a email service provider. So yeah, And then let's talk about this final scenario, a webhook that uses Microsoft Graph to update an Excel sheet. So since this function is triggered by this webhook, the trigger is HTTP, and we don't have any input bindings, but you know that we are using Microsoft Graph to update an Excel sheet after processing data in the function itself. So here in this scenario, the output binding would be a Microsoft Graph. Yeah, then let's move to the hosting options. So when it comes to Azure Function Apps, guys, you know, we have to, I mean, we are hosting this resource in the cloud in Azure. So when it comes to the hosting, we have a couple of hosting options. So I think you guys had the chance in the app services session to know more about these hosting options. Same as app services, you can have multiple hosting options here in the Azure Function Apps as well. So the hosting options would not be the same, but we have some hosting options here in Azure Function Apps as well. So the first option would be this, the consumption plan. So here, this is the default hosting option when it comes to the Azure Function Apps. So here it scales automatically, and you have to only pay for the compute resources when your functions are running. So if your functions are idle, you don't have to pay for just for hosting in this consumption plan. But there's a small downside in when using a consumption plan. So uh, when it comes to the consumption plan, there could be cold starts happened uh, when using consumption plan. So if I explain this term cold start, it's like this. So after your function app has been idle for like number of minutes without any invocation, the platform may scale the number of instances of your apps down to zero. So in that case, uh, the number of instances in your function app would be scaled down to zero. And when the next request has added to the, I mean, when the next request invoke this function, it could be adding some latency from latency of scaling this instance from 0 to 1. So this latency is mainly referred to as a cold start. And so based on the number of dependencies you have in the function, this cold start latency can be varied. So you have to keep this in mind when you are using consumption plan. There can be some uh, s- yeah, yeah, sorry about this, guys. So okay, yeah, I was talking about this consumption plan. So when you guys are using consumption plan, you guys have to consider about this cold start as well. And then we have this premium plan. It's kind of, as the name depicts, it's more premium option. So here you don't have to worry about cold start because always in the premium plan you have these pre-warmed workers. So you don't have to worry about scaling down to zero instances when the functions are idle. So it's kind of more premium plan, and also it will incur more cost as well. So we'll look at these options when we are creating the functions in the portal. And then of course we have this third option, dedicated plan. Here, you know, in the session of Azure App Services, I think you have noticed that we have to create this different resource called App Service Plans to host these app services. So here in Azure Function Apps, you can use these app service plans to host these function apps as well. So this option is more suitable when you have existing underutilized VMs that are already running other app service instances. And if you want more predictive scaling, I mean, as I mentioned in other two options, it's kind of more auto scaling. If you want more predictive scaling options, and also you have to, I mean, when it comes to cost, you have to be more predictive. This option would be the best option when it comes to hosting plans. Yeah, these three are the hosting plans we have in Azure Function Apps. And then let's move to the next slide. All right, let's talk about the scaling. Yeah, so here scaling, I'm only talking about these three plans in this session. So I'm not going to dig deep into scaling in this session. So when it comes to consumption plan and the premium plan, you kind of have this event driven scaling. So basically in both these two options, the scaling is done automatically. And I mean, the scaling out and the scaling in both happened automatically. But when it comes to the dedicated plan, based on the configurations you have added to the app service plan itself, you can configure the scaling manually or automatically. So the both options are available when it comes to this hosting option, the dedicated plans. And yeah, and then I have added a couple of use cases, scenarios you can use Azure Function Apps to, I mean, where you can use Azure Function Apps to achieve your end goals. So for the first use case would be process data uploads. So here you can see in this diagram, you have this function here. We use to process the data uploads through this blob storage. So here you can trigger this Azure function from this blob storage uh, data uploads, and also you do the processing here, and you can send this process data into another service or another system any way you like. So we can have this kind of architecture to process data uploads. This is the first use case. And the second use case would be real-time stream and event processing. So, in this system, you have this function triggered by these event hubs. So into these event hubs, a app or device produce data, and this event hub ingests telemetry data from this coming from this app or device, and this function is triggered from the event hub, and you can process data and output these data into a database or any other service or system as you like. So this is a one use case. And then yeah, the third use case would be run scheduled task. So here you have this function. This function is supposed to clean a database in every 50 minutes. So there you can have this function. You can have this function as a timer trigger, and you can configure the trigger intervals to 15 minutes. So you have these input bindings from this Azure SQL database, and you process data inside the function, and deduplicating entries based on the business logic. So yeah, this is another use case. And yeah, then we have this build a scalable web API. We can use Azure Function Apps to have multiple HTTP trigger functions, so that we can use these function apps as a full-fledged web API. So you have this web HTTP endpoints in this function. So based on the request, this is triggered. And also, as I mentioned, in other scenarios, you can have multiple output bindings as well. You can call another service, you can call another, a system, whatever you like. You can have multiple output bindings here as well. And yeah, finally, we have this use case respond to a database change. It's kind of more more common scenario here. You have this database and the function here. This function is triggered based on the changes we do in this database. It can be either a Cosmos DB or a relational database like Azure SQL. So based on this database change, we process this change, and we can maybe we can send out notifications to the administrators of this application saying that this change is done to the database. You have to, likewise, you can process this data. All right, so these are kind of use cases. Some of the use cases you can use Azure Function Apps in your systems. And let's now talk about the Azure App Services and Azure Function Apps. So I think you guys might have some confusion in between these two services. So let's start from the key differences. So Azure, when it comes to Azure App Services, this service is mainly designed for building and hosting web applications that may have more complex functionalities and require full application platform. But on the other hand, Azure Function Apps are tailored for smaller unit of code like functions executing in response to a specific trigger or events, commonly known as serverless architecture. And when to you, when to choose Azure App Services. So opt for Azure App Services when building full-fledged web applications that require a server, a stateful operations, and complex functionality. So basically, it's ideal for web applications, APIs, and mobile backends that need more control over the underlying infrastructure. So when it comes to the Azure Function app, use Azure Function apps for like microservices, event-driven tasks, small automation jobs, and serverless computing models. Like for scenarios like where you need run code in response to an event and execute short-lived function. So Azure Function apps are more suitable. So just consider, based on your scenario, just consider what kind of services you have to use based on the things I described here, guys. So basically, it depends on your situations actually when choosing the correct service for your system. All right, so then let's move to our first demo, creating and deploying Azure Functions. So in this demo, let's first create this Azure Function app resource. So here I'm at the Azure portal. Let's click on create resource. You can search for function app here, or you can see here also it's available. Let's click on this. And then you guys can create or select a resource group. I'll create one. And you have to put a unique name for your function app. Let's say, yep. And you can choose the runtime stack. Here, there are many options available for your programming model. So for this demo, I'll choose .NET since I'm more familiar with .NET. So I'll put the .NET version here. I'll choose 6 isolated. You can select the region and you can select the operating system. So I'll choose Windows. And here you can choose what hosting option or the plan you are going to use. So for this demo, I'll choose consumption plan. Let's move to storage. So to run an Azure function app, you have to have a storage account, separate storage account. So then let's do networking. So I'm not going to explain more onto the networking and stuff here in this session. And we have the monitoring section here. For the moment, I'll disable the application insights for this application. So basically, this application insights service is kind of a we can use to store. We can explain. I mean, we can send our log related data in our application to this application insights service. It is a separate service. So where you can do monitoring on your other services, and you can kind of configure alerts and all the things in this application insight service. But I'm not going to explain or dig deep into application insights in this scope. So I'll disable it for the moment. Deployments, you can configure GitHub Actions here, but it's not included in this scope. So you can define tags and then review and create. And yeah, I'll click on create. So, guys, when creating Azure resources, this might take some time. So to save our time, I have already created a function app. Yep, here. So yeah, here you can see I have created this func afg demo function app. Alongside with that, you can see we have the function app, and we have this resource storage account related to this function app, and also we have this app service plan where we have deployed this function app into. So all these resources are created when we create this function app itself. So the, as I mentioned, this management is handled by the Azure itself. And let's move into the function app. Yeah, let's refresh. Okay, so in the main screen, when you navigate firstly into a function app, you can see the resource group and the URL where you can use to access this function app, and all the things are here. And in the left panel here, you can see there are many options and many operations you can do for this function app. But here I'm not going to explain each and every these options available here. But anyway, I'll go through some important options here. So first, let's look at these app keys. So in a function app, or when it comes to a function specific, we have this authorization level. I'll explain this in a bit, but when it comes to this authorization level, it's really important to have an understanding about the keys of the function app and the functions itself. So in the function app level, you have uh, two keys by default. One is the master key and the one is the default key. You can uh, see the values here. Same as the function app level, in the functions level as well, you can have function specific keys. I'll show you in a bit about these function keys. And then we have configurations. So in the configurations, you guys can store the application settings. We are going to be using in the code executions in our code level. So I'll show you the use cases of these in a bit. Anyway, in the configurations, we are storing the application related settings, and you can enable application insights for this application Azure function app, and you can have custom domains defined. So by default, you have this default custom domain. You can buy any custom domains and define or uh, configure those custom domains for this Azure function app. And you have this networking section where you can configure security rules and inbound rules, the outbound traffic rules, and all the things here. And yeah, that's about it, guys. Now let's try to, by default, we don't have any functions here. Now let's try to create a uh, project using Visual Studio. Here I'm going to create a Azure Function app project using .NET programming module. There, what you have to do is you can click on New Project, and you can select search for Azure Function apps here. Oh shit. Yeah, you can see this Azure Functions option here. You can click on this and click on Next. You can give any name you want and select the solution and the solution name and click on Next. And here you can select the functions runtime. So as I selected .NET 6 isolated in this function app itself, I'll select the same runtime worker. And when we create this project, by default, it will be creating a single function, the default function. For that function, I can select any of the triggers available here. As you can see here, we have many triggers we can choose from. So for the moment, I'll choose HTTP trigger, and authorization level here. We can choose what kind of authorization level we need for this particular default function. So when it comes to authorization level, guys, we have three uh, authorization level: anonymous, function, and admin. So if you choose anonymous, you don't have any authorization to be done when it comes to accessing your functions. But if you choose function, you have to, I mean, as I mentioned earlier, you have kind of two kind of keys in the Azure Function apps. One is at the Azure Function app level. So you have this master key, and even in the functions level, you have kind of function specific keys in for functions. I'll show you that keys in a bit. But anyway, if you choose functions, you have to use function specific keys to access this particular function. And if you choose admin, you have to use the master key specific to the Azure Function app to access this function. So for the moment, I'll choose anonymous, and I just have to click on this create in order to create this function. But anyway, to save some time, I have created this function project already. So, so by default, it will create this kind of project here, a solution. Here you have the default function, the function one. You can see the Visual Studio itself is creating this code line for the function one. And here you can see the authorization level is configured, and you can define. And by default, it's allowing both get and post type of HTTP request, but you can define whether to have get or post, or you can define multiple request type as this. And here you can define by default the route is will, I mean, the route part is not will be there like this, but you can define custom routes for this particular function like this. I'll show you how this works in a bit. So anyway, what this default function do is it does return, it triggered by this HTTP trigger, and it will return this string value function one and the authorization level as anonymous. And to demo out the authorization level, guys, I have duplicated this function one and have two another functions. And here the main difference would be the route here, and also the authorization level for function one is anonymous, and for function two it's function, and for function three it's admin. So now we have three different functions. So you can define functions in the same file, or you can define functions in separate functions. So it's actually based on your, uh, I mean, your practices you follow. You can define functions wherever you want. And then let's try to run this function locally first. So basically it's building the project first, and all right. So the app is up and running now. You can see we have 3 functions here. Uh, you can see the custom route we define is here. You can take this URL and let's go to the Postman. And if we run this one, you can see the desired output. This string output is we are getting this string output as function 1, and the authorization level is anonymous. So yeah, that's about defining functions, guys. So now yep, let's let's try to publish this code base into our function app resource. So when it comes to publishing your code base, there are several uh, methods. For an example, as the general practice in real world projects, what we do is we kind of define CI/CD pipelines to release in this project the code base into our Azure resources. But in this session, in this demo, what I'm going to do is directly publish this code base into our Azure resource. In order to do that, what you have to do is right click on this solution, and then you have this publish. Then you have to click on Azure Function App Windows, and then you have to log into your Azure account. I have already logged in, so that I don't have to do that anymore. And then you have this resource groups available here. You can click on uh, the function app you want to here, and you can click on finish. And this will create, this will generate the publish profile for your function app. And so using this publish profile, you can publish this code base into your function app. So guys, I have already done that. So this will take some time. So now you have this publish profile. You can click on this publish in order to uh, publish your code base into your Azure resource. But I have already done that. So once you have published this code base into this function app, here in the home page, you can see under functions, you can see our 3 functions, function 1, function 2, and function 3. And this queue function I'll explain in a bit. But anyway, at the moment, we have these 3 functions. Okay, now let's try to invoke these functions in our uh, Azure resource. So for that, I have to have this public URL for that particular Azure function app. Then I have to use these URLs here. So let's try to invoke function 1. As you can see here, it's returning as expected. Now let's try to invoke function 2. As you can remember, the authorization level is function. So now we are getting 401 unauthorized response because we are not using any of the function specific keys here. For that, let's move to the function 2 and let's move to the function keys here. And here you can see we are having this default key. So basically you can copy this part, and in order to get authorized for this function, you have to add this code to the query parameters of this request like this. Now let's try invoking this one. So as you can see here, we are getting the 200 results with the expected invocation. Now let's try to execute the function 3 using this function specific key of the function 2. So this is the expected result. We are getting the 401 unauthorized error. Now let's go to the function app and let's take the master key of this function app. Let's copy this code And let's try to replace this function specific key with the master key. And let's try again. So now it's we are getting 200 status with the expected string response. So this is kind of the use cases of authorization levels and different keys, the function specific keys and the master keys. And with that, I have concluded the first demo, creating and deploying the Azure functions. And in the next demo, what I want to show you guys is how we can integrate other Azure, I mean, other services with this Azure functions. For this, guys, I'm going to do like this. So I have this. Mm, I have created this service bus uh, in our resource group. This is a separate, Azure service where we can have queues and topics and all the things. So here, guys, I have created this AFG demo queue. So this is pretty much a service bus queue. So basically in this demo, what I'm going to do is I'm going to create a function which can be triggered from this service bus queue and return, return the messages we send from this particular queue in that function. So for that, what we can do is, guys, we can create a separate function here. Right click on the solution and you can click on add and click on new Azure function, and you can specify the name function. And here in the first demo, we use this HTTP triggers, but now I'm going to use service bus queue trigger. So here you have to specify the connection string application setting name. So you can choose like this SB connection, let's say SB connection. So this would be the application setting name where we mention the connection string to this specific service bus. So I'll explain in a bit this one, and I can specify my desired queue name for the uh, queue. And when I click on the add, it will add the function itself. I have already added this function, guys. So let me show you guys this queue function. So as you can see here, this is the function which is triggered by the service bus queue. And this trigger type is kind of different. As you can see here, the trigger type is service bus trigger. And here I have mentioned the service bus queue name, and the connection. For the connection parameter, I have passed this application settings name. When it comes to the application settings guy, I have to create this SB connection application setting inside. If we are to use in the development environment, I have to define this application setting in this local settings.json file. So as you can see, I have already defined this one SB connection, and I have put the connection string of the particular service bus here. And when it comes to the Azure resources, yeah, here in the Azure function app, you can configure these application settings as I mentioned earlier in the configurations. Uh, yeah, configurations, and you can define under application settings. You can define this particular settings here. So I have already defined it. So we have this SB connection and this connection string as well. And what this function, this particular queue triggered function does is basically it logs the data, the message details received from this particular queue. So I have already published this function to this particular function app. You can see this queue function is already here. So let's have a duplicate tab here, and let's go into the Azure function, this queue function, and let's go to the code and test. So here what I'm going to do is I'm going to publish or send a message into this particular service bus queue. For that, let's move to the service bus. So then we can see how this function is behave. So let's enable logs here for the function. Okay, it's connected. And now what I'm going to do is I'm going to go to the this AFG demo queue. And then let's go to the Service Bus Explorer where we can use to kind of send messages or the peek into messages, things like that. So initially you guys can see there are no any logs here apart from the initial log. Now let's try to send a message. Let's kind of have a plain text message here. FG demo, let's say session 8. Now we can send this message into the queue, and let's look at the logs now. So as you can see here, guys, this function is getting triggered from the queue message, and you can see here, you can see the message ID, the message body as AFG demo session 8. So basically my point is you can integrate different services like this service bus queues and logic caps. I mean, like the Cosmos DB, you can integrate different services with Azure Function apps, and you can use different types of triggers to execute these functions as you like based on your scenarios. Yeah, that's about the second demo, guys. So I hope you guys get some sort of complete knowledge, not complete, I mean, at least some basic understanding about how Azure functions are working in the portal and the code base and all the things like that. And now let's quickly move into the last section of the session. So since our time is running out, I'll try to cover this part, the Azure durable functions in a, I mean, as in a brush way. But the thing is, uh, if we are to talk about the Azure function apps, it's really important. I mean, to have a complete understanding, it's important to have this understanding on this Azure durable functions. So that's why I thought to give you guys an basic understanding about durable functions as well. So here I'm not going to dig deep anyway, hoping to give you guys the basic of the Azure durable functions here. So let's start from this question. What are durable functions? So I would say this Azure durable functions is kind of an extension of Azure functions that lets you write stateful functions in a serverless compute environment. So I mentioned in the uh, basic Azure functions, those functions are stateless. So basically you can't manage states in these functions, but using Azure durable functions, you can at least write stateful functions in this serverless compute environment. And the primary use case for durable functions is to simplifying complex stateful coordination requirements in serverless applications. And this Azure durable functions allow developers to write orchestrator functions to coordinate multiple Azure functions and manage stateful workflows efficiently. Here, guys, it's really important when it comes to Azure durable functions to understand the concept called this workflows. When it comes to Azure durable functions, you have to define your workflows precisely in order to have the, I would say, the in order to have the most benefits of using this Azure durable function. So defining a workflow is very important here. I'll explain about these workflows in a bit. So anyway, uh, these durable functions allow you to have uh, a coordination in between multiple Azure functions and to have a define workflow accordingly, according to your scenarios. And let's talk about building stateful workflows now. So basically, durable functions, as I mentioned, it provides a way to define workflows using code and manage long-running and stateful operations. This the state we are talking about in durable functions is managed transparently, so allowing the developer to focus only on the business logic. And I was talking about building stateful workflows and defining workflows and all the stuff. They are in the documentation itself. They are providing many patterns when it comes to defining or building this stateful workflows. In this session, I'm not going to explain. I mean, there are like 5, 6 patterns there, but I'm not going to explain all the patterns here. But anyway, I'm going to take 2 patterns mainly. And when it comes to building stateful workflows and explain to you guys. So the first pattern would be function chaining. You know, as the name depicts, you can see in this diagram, uh, in this kind of workflows, we have multiple functions. Uh, I mean, they are connected in a way of a chain. So the function one is executed firstly, and the subsequent functions F2, F3, and F4 are going to execute. For an example, let's say if F2, it's going to be executed right after the execution of F1. F3 is going to be executed right after the execution of F2. It's kind of a sequential execution. So this pattern is known as function chaining. And then the second pattern is fan in and fan out. So, you know, if you pay attention to this diagram, we have this function one. From function one, after its execution, you can fan out to several functions. You can execute these functions parallelly, and then again, you can, after this execution of these functions, you can fan in to this single function F3. So I mean, when it comes to building stateful workflows, it, as I mentioned multiple times, it's based on your requirement. So in some scenarios, you can have this kind of function chaining workflows, but in some scenarios, you may have to have this kind of more complex fan in, fan out type workflows for your durable work. I mean, for your durable functions. So yeah, as I mentioned, there are many patterns available. You can refer it in the documentation, but I'm not going to explain other patterns in this session. And then I'll quickly explain about the types of durable functions available. As I mentioned, there are different types in when it comes to Azure durable function. The first function type is orchestrator functions. This is kind of the main function. It defines the workflow and coordinate the execution of other functions. We can say for a workflow, there can be this main function. We call this as orchestrator function. And also in some complex workflows, you can have multiple sub-orchestrators as well. So you can have multiple separate workflows in the main workflow using the sub orchestrator functions as well. So these orchestrator functions manage the flow of activities, handle errors, and they maintain the state of this particular workflow. And then the second type is activity functions. And these type of functions perform specific tasks within the workflow. For an example, let's take this one. We can say this F2 is activity function, things like that. So basically, these activity functions are responsible to perform specific tasks within the workflow. And these activity functions are always invoked by the orchestrator function. And they are granular and can be reused in various workflows. And then finally, we have these entity functions. So basically, these entity functions define operations for reading and updating small pieces of state known as these durable entities. So these functions provide a way to manage these stateful entities. So yeah, when it comes to these durable functions, we have these three types: orchestrators, activities, and entities. And then let's quickly talk about the real world use cases when it comes to Azure durable functions. You know, if you have any long running workflows, for an example, order processing, approval workflows, or like complex data processing that requires multiple steps, and these workflows may require some long running, I mean, long durations to execute. You can think of using Azure durable functions. So, you know, when it comes to the standard Azure functions, you can't have long running execution. For an example, I can't remember the exact duration, but I think it's like 5 or 10 minutes. Uh, I mean, I mean, the upper limit of the execution would be the 5 or 10 minutes there. But in when you have these durable functions, these durable function workflows, you can have long running executions here in durable functions. And the second use case would be stateful entity management. So the applications like that need stateful storage and retrieval across multiple function calls. You can define durable workflows, these such scenarios, and you can definitely use Azure durable functions. And yeah, finally, let's do a quick comparison in between the standard Azure functions and the Azure durable function. The first and most obvious one would be this statefulness of the Azure durable functions. As I mentioned in the previous slide, in the standard Azure functions, you can't uh, manage states inside the functions. If you are to manage states, you have to have external services like databases or caching mechanisms, things like that. But in durable functions, you can manage states without worrying any uh, consequences. And yeah, the second point is for durable functions, we can use durable functions for long running and stateful workflows. But I explained this point earlier as well. But in standard data functions, you can't have long running and stateful workflows executed in this standard data functions. But in Azure durable functions, you can. And in scenarios like you have to have coordinations in between multiple functions inside the Azure function app. I mean, you can't use standard Azure functions, but using Azure durable functions, you can have this coordination in between multiple functions. So I explained these patterns, couple of patterns here. As you can see here, there is a coordination in between multiple functions. So when it comes to Azure durable functions, you can have this coordination. Yeah, uh, these are the main 3 points when it comes to the comparison. And I think with that, I have come to the end of this session, guys. So I hope I was able to give you guys some sort of understanding about Azure Functions and how it works, and how the integration could work with other services, and of course the durable functions as well. So yeah, thank you for your time, guys. If